Welcome. In this video we'll be talking about how to multiply monomials, but this time with positive or negative exponents. So to begin, I want to review some of the rules of exponents, at least one of the rules that we've talked about thus far. So we've talked about this rule number 1, which is if you're multiplying like bases together, so x to the second times x to the third, for example, means I have 2 factors of x here times 3 factors of x here. And so the shortcut to knowing how many factors of x I'll end up with is to add the exponents. So what we end up with is x to the 5th. The second rule is dealing with negative exponents. And so notice here I've got an expression written and the exponent on the y is negative. Well, there's an equivalent way to write this expression so that we don't use a negative exponent. And the way to do that is I'm going to leave the bases with positive exponents just as they are. So x to the second and z to the fourth are what I call happy. They already have positive exponents where they are, so they're not going to want to move at all. Y to the negative third, there's another way to write this so that the exponent isn't negative. What I'm going to do is flip the entire base to the bottom, and actually in this case to the bottom, because the exponent is negative when this guy's on top. And when I do that, notice that the exponent stays as a 3, but it changes to a positive 3. If I were to move this z to the fourth on top, it would become z to the negative fourth. If I were to move this x to the second to the bottom, it becomes x to the negative second. So when you move bases to the other side of a fraction bar, it basically is going to switch their exponents to the opposite sign. So it's an easy fix. If I see a negative exponent, all I do is flip it over the fraction bar, the whole base, and the exponent number stays the same, it just changes sign. So we're going to use that fact to help us to simplify the expressions on this page. So starting with number 1. The steps for this is for simplifying this is going to be about the same as for the equivalent problem with just positive exponents. So the first thing we're going to do is to group like objects. So again, with multiplication, I can switch stuff around. So what I'm going to do is put all of my numbers first. So that's the 5 times 2 times 5. And then I guess I have some choices here. So I'm just going to do the u's next. So that's u to the 6th, u to the second, and that's it. And then I'll do the z. So I've got z to the negative third, and z to the second. And then I'll do the w. So I've got w to the negative 5th and w to the 5th. So if I multiply what I have, well, that's my step 2, is to use rules of exponents. So I start with rule number 1. And I'm multiplying like bases, so I'm going to start by multiplying these numbers together. So 5 times 2 is 10, times 5 is 50. And then I'll have u to the 6th times u to the second. Well, if I use my first rule and add those exponents together, it gives me u to the 8th. Z to the negative third times z to the second. If I add those exponents together, I get z to the negative 1 power. And then w to the negative 5th times w to the 5th gives me w to the 0. Okay, now notice how I have a base with a negative exponent. So I have to fix that. And when I say fix it, I'm not changing the value of what I have, I'm just writing it in an equivalent way. So what I'm going to do, since I don't have a bottom currently, is I'm just going to make one. And I know that z is going to move to the bottom. The exponent number will stay the same, but it's going to switch signs. In terms of the w to the 0, well, anything to the 0 power is just 1. So this just becomes times 1. So then, what I'm left with is 50u to the 8th, and on the bottom I don't need to write z to the first power, I could just write that as z. Alright, I want you to try number 2, pause the video, and then restart it after you've given it a try. So number 2, it's a similar story. I first put the numbers together, so I've got 3 times 2 times 4. Then I'm going to do the y's. Then I'm going to do the t's. Then I'm going to do the x's. And now if I multiply my numbers together, I get 24. And then multiplying my like bases, -3 plus -1 is y to the -4th. I've got t to the 0, -3 plus 3 is 0. And then -2 plus 4 is +2, so I've got x to the +2 power. Okay, if I take care of my negative exponents, well, this y to the -4th is going to jump to the bottom and become y to the 4th. Everything else is going to stay right where it is. Notice 24 doesn't move because 24 has its own exponent. It's just a 1. So it's going to stay right where it's at on top. The x to the second is also going to stay on top. And t to the 0, again, cancels out. So it just becomes 1, which has no impact on my final expression.